Alright, so we got a lot going on with hyperbolic functions. Hyperbolic functions are used for modeling many real-world problems, such as determining how to design a suspension bridge. Okay, and hyperbolic functions actually come about because if we were to actually write sine and cosine as a function of e to dx, we would have imaginary numbers in there. So hyperbolics get rid of those imaginaries, and this is where they actually come from. Okay, alright, so how do we pronounce it? Hyperbolic sine of x is actually sinh of x, and hyperbolic cosine of x is just cosh. It's like gosh, but with cosh. Okay, so here's the identities. As you can see, the only little difference is that there's a minus sign in the identity for the hyperbolic identities, the Pythagorean one. Okay, and that kind of changes up the signs in the other two type of identities. Okay, and then in this hyperbolic identity right here, we're dividing by 2. Okay, now list of derivatives of hyperbolics. Okay, the derivatives of sinh of x is cosh of x, and the derivative of cosh of x is sinh of x. Okay, and then here's the others right there. All right, I'll now pause it if you want to write these down as you go, but they're pretty straightforward. They're pretty much like the trig derivatives and everything, except for the little differences. Like, for example, there is no negative versions right there. Okay, all right, now we got a lot to go with. Okay, so the integrals of the hyperbolics are going to be listed right here. Okay, so there's all that. Okay, and then the hyperbolic inverses are listed right here, and as amazingly enough, there's going to be a lot of similarities in there. Okay. All right, now the derivatives are going to be different. Okay, and there's some important rules that you have to pay attention to over off on the side, so make sure that you're following these rules as you're going along. Okay, but here's a list of all of them, and if I scroll down a little bit, okay, we've got the integrals of the other types of functions. So let me put in there little fraction bars, forgot to put that in earlier. Okay, as you can see, they're similar, but they're not exactly like the integrals of the inverse functions of the inverse. Okay, all right. Now here's a unique one right here. I'm just going to point it right out. This could actually be one of two things. This could be the integral could be 1 over a times the arctanth of x over a if u squared is less than a squared. Okay, and in this case it's not actually u, it's actually going to be, let me change these up to x's. Alright, there we go. Let's move it back to its original. There we go. Okay, so if x squared is less than a squared, it's going to be arctanth, and if x squared is bigger than a squared, it's going to be arccoth. Okay. Alright, so here's all the rules and everything, and just working with it. Just take your time when working with this stuff. Remember, you might have to complete the square on some of these to actually get them so you can actually get the integral of them. Okay? Alright, that's it for working with hyperbolic functions. I wish you good luck, and ask me for any help if need be. Thank you. Bye.